Okay, so we look at the first question now. There are three identical beakers, P, Q, and R. They are filled with equal amounts of water of different temperatures. So the beakers were covered with identical lids and placed on a table, okay, in a room with a temperature of 28 degrees Celsius. So the room temperature is 28 degrees Celsius. Of course, when you look at questions like this, you need to annotate, okay, to remind yourself there are all these information in the question. All right. So there's PQR filled with equal amounts of water. Yep. Different temperature, covered with identical lids. Okay, this is environment of 28 degrees Celsius. Now, water droplets were formed. So water droplets were formed on beakers Q and R as shown. So where are the water droplets? They are here for Q, which is on the inside. And for R, the water droplets are formed on the outside. Okay, so can you recall incidences where you see water droplets on the outside? Like, for example, some of you put a glass of water, or maybe this bottle of mineral water, okay, is put inside the fridge, okay, for a day or two. Then I took it out, I put it on a kitchen table. Do you see water droplets on the outside for me? Yeah, it seems like the bottle is sweating, but it doesn't sweat. Okay, it's not perspiring. This is not sweat. This is actually vapor in the air condensing on the surface. Okay, so yes, the water is cold. Thank you so much. So cold over here means this is cold water. What about Q? What can you say about Q? Hold on, I marked Joven's attendance. Joven is here. What about Q? What's the temperature of Q? Give me some examples. Let's see. Wei Le, are you here, Wei Le? Okay, good, Joanne. Yeah, good suggestion. Joanne said the temperature is around this value. Okay, so Wei Le, can you tell me, is there any example you can think of about Q? Okay, like maybe you can see I have a cup here. What do you think is the temperature of the coffee I have now? Okay, I took out the lid just now. There was a lot of water. Okay, do you think this is my iced coffee or this is my hot coffee? Hot coffee, okay. Why do you say that? Yeah, some of you are already typing in. You're telling me some explanation. Now, this is a kind of question about water. You all know, right? It's about water. Water consists of two parts, right? There's a changes of state. Okay. And there's the water cycle. Okay, you need to understand there are two parts to this. Very good. Okay, wait, let's say because water droplets only fall on the inside. Okay, because the water is hotter. Why is it that water droplets form on the inside here? If I were to ask you, explain how the water droplets are being formed inside this container, how would you write down your answer? Okay, I want to see some responses here. Let's see who can give me the right explanation. Hanson, you want to try as well? I think you've completed your survey, right? Willa, I like your explanation here, but you can actually write more. Why is it that water droplets are formed on the inside? Vinuli, type in as well. Xuan Xuan also must type in. I know you are too relaxed already today. So I must call names to give me the answers. I will let you play some look at game later, for sure. But you must respond. Let's quickly finish this worksheet, right? Then let me share with you what will happen next week. Then we will play the booklet, right? Some of you will be interested to know what will happen next week. But I think I've said it before. Okay. Yep, good. I see someone writing. So there is something like this, right? Correct. What is this thing? Yeah, very good. Thank you for writing down. Pinuli, you're typing also good. I can see. Mm-hmm. All right. Right. So there's this whole thing is made out of hot water, right? So water at the surface, yes, evaporated into hot water vapor. Okay, and then the hot water vapor came into contact with the cooler inner surface of beaker Q. Well done. All right, so lose heat, yeah, and condense into water droplets. Thank you so much. Okay, Jia Qi gave a very long answer. All right, so let's see. Shen Shen, where's your answer? Just show me your answer. I think the most important thing is you cannot be shy to show me your answer. Be it too short, be it not enough, I will give you the comments. Yeah? Shen Shen, you are like, which is why our messages, we don't see everybody's answers, you know. Yeah. Only mistake can see. Okay. So you talk about the water at the surface, right? Yeah, water at the surface evaporated into warm water vapor. Okay, so the warm water vapor rises, touches the cooler inner surface of the lid. You can talk about the lid. Loses heat and condenses to form tiny water droplets. Yeah, let's see. Yes, surrounding hot water rises, come into contact. Don't say hot water rises. Hot water cannot rise. It's the water vapor that rise. No worries, you are almost there. You just need to include some words, okay, which came into contact with the cold surface of beaker Q. Be very specific, it's the lid, okay, it's the lid. If you can write down lid, it will be very good. Okay, yeah. You need to, don't just say condensation takes place. You must say that the hot water vapor loses heat and condensation takes place, yeah. Very good, Vinuli. When the hot water evaporates, it gains here, evaporated into water vapor. The warmer water vapor come into contact with the cooler inner surface of the lid and then loses heat and condense into water droplets. Okay, so this is Vinuli's answer. Okay. All right. So I want to advise you not to write down it will then lose heat, because you don't know whether it's the lid losing heat or is it the water vapor losing heat. Right now, Vinuli? Yeah, so only that part. The later part, you use the word it. That is a concern. Just that. All right. So what's the answer over here? Which do you think is the beaker which had the temperature change? Okay, there's a drop, you know. So this particular beaker contain water, right? At a specific temperature. After that, this water starts to cool down, because you can see the temperature is going downwards, right? So it's getting lower and lower until a certain temperature. Okay, which beaker will have the water, having this temperature change? It has to be the beaker Q. Why beaker Q? Okay, beaker Q is hot water. Okay, beaker Q is hot water, so it's hotter than usual. It will cool down. Now, I want someone to tell me what is this temperature? Can you all guess? Wait, turn on your camera, Wait, the rest of you also turn on the camera. Very good, Joanne. Thank you. Who else can give me the answer? Have a specific value to it, Joanne? If I ask you to give me a certain number, how many degrees Celsius do you think? Okay, good, Joanne. Very good. The rest of you? This is room temperature. Very good. Remember, even if we were to put our hot water, okay, and imagine my hot coffee, yeah, I just leave it on the table, I forgot to drink it. It will cool down, isn't it? And then it will be the same temperature as the room temperature. It cannot go down beyond that, okay? It cannot go below that temperature. It cannot change to other temperature. It can only reach the surrounding temperature. Okay, the heat loss and heat gain, right, will always continue until both areas have the same temperature. In this case, the same temperature we're talking about is room temperature. Room temperature is already indicated, and I circle it in the beginning of the lesson, right? Or the beginning of the question. I circle it 28 degrees Celsius. So we will write this down as 28 degrees Celsius. I am very sure next year you will see questions like this asking you, what is this temperature? You all better listen up. So next year you will see questions like this. All right. Next question. Now, we usually look at the circulatory system this way, right? The diagrammatic representation is only by boxes. You don't see the drawing of hearts, etc., and so on. Remember, you don't see that. So you don't see the drawing of lungs, etc. Even in the exam, you are only required to draw this if they ask you to draw a diagram to represent how blood flows. So we know that blood flows from the lungs, which carry a lot of oxygen, to the heart. The heart then pumps, okay? The heart then pumps the blood, rich in oxygen, to other parts of the body. In this example, or in this question, you see legs, right? So we can write down other parts of body rather than just legs, because it can be the hand, okay? It can be your buttocks, it can be your thighs, it can be your shoulder, anywhere. Okay, so other parts of the body. Now, so this is the one that we are familiar with, right? So after the blood has gone to other parts of the body, it needs to go back to the heart, okay? And eventually the blood will go to the lungs. Why? Because carbon dioxide needs to be removed, okay, from the body. And the blood will then take in more oxygen now, and the circulatory system continue its work, something like that. Clear? So it moves in this manner. That's why it's like called the circulatory system, because it moves like in a circle, the kind of thing, round and round, doesn't stop. Okay, so now this question asks you something else, right? I'm going to ask you, okay, if this is the direction of blood flow, okay, like comparing top to bottom. Okay, so we have the lungs and the heart around the same level. Okay, then after that, the lower level is the legs. Where will be our head? Head, I can actually, let's say, draw it here, right? With a box. Yes or not? Correct? So blood will also flow from the heart to the head. Yes or no? With a lot of oxygen. Then after that, after the blood has passed through the head, oxygen is used up for respiration. The blood will carry more carbon dioxide now. Yes or no? So it moves this way. Now I'm going to ask you another question. Do you think blood can flow from the lungs straight to the head? Then after that, from the head back to the lungs? Is that possible? No, you got to know this. It is impossible for blood to flow directly from the lungs to other parts. It must go to the heart first. Okay, so this is not possible. The blood that carries oxygen must go to the heart first. This blood will then be pumped to all parts of the body, including the head. Okay, so don't say that, oh, because head is positioned right above the lungs, then I draw the arrow directly. It cannot happen. And the blood from the head carrying a lot of carbon dioxide must go back to the heart first before the blood can go back to the lungs. So this is how the blood moves. must remember.